Today we are going to see the state-based analysis, right? So the state-based analysis is used for solving a problem in control system as multiple input and multiple output, and in between we are having many state variable. Now directly we will go for a simple problem. You can go through that one, right? So now you have to what is the state-based analysis, right? So you have to consider a set of variable as the states, right? So here, for example, now you see the diagram. You consider whatever the system, we have to take that system as you have to take that modern control system, right? So here we are having now many. You have seen that one. We are having now many devices or many instruments are connected here. Some is a one total the industry control. Now for that industry control, we are giving now many set of input, many applying voltage or current or something we have to apply. Now here each and every places, then you have to check the current status of that particular plan, the particular block or particular module, then we have to find out the, so that is we have to consider now as a set of state. What's the current state? Right? Then we are going to have now that what is the result as output. So if we are having a big control system, then we have to give multiple input, multiple output, and a set of states, right? Now we have to consider this is a vector, input vector. So this is output vector, and here you have to consider now this is a state vector, right? So you have to consider now as a vector. So you are having now that matrix, right? So that is the representation here, right? So that x is here we are having now the state variable vector. So that one is x1 to xn, and then we have to write that representation as here. So for each and every state, then here we have to consider now the previous state of that x1, x2, x up to xn, and then the coefficients. So that coefficient is we are having now, right? Then you have to add it with the another coefficient with the input vector. Input. So input here we are having now the corresponding input for one particular input. So what's the cases now? Now here you have to take this one as this is the collection of that state linear differential equation. So differential equation. So this is actually we are having the differential equation for that each and every state variable. Now the output also you have to consider now that vector, and you have to take that one as coefficient C1 and C2 up to Cn. This one, right? Now you are having now the in vector form, then we can write the simple equation as the total one is going to be represented by vector model, right? So that is capital X is consider now this vector, capital X. And then the A part, right? A11, A12 up to A1n. Then this is one matrix. So here we are having now n cross n matrix. A11 to ANN. N cross matrix is you have to consider now this is A. Then X of T is X1, X2 up to Xn. So this is one column vector as X1, X2, X3. Then here we are having now B is here the vector, right? So this coefficient vector for input. Then we are having now that output is coefficient vector and multiplied with the column vector of the variable, the state variable, right? So you are getting now, this is the equation, right? Now we are getting now this is a state space equation. From the state equation, how do you find out the transfer function, right? So this is state equation is we are having now the state equation that t is actually 0 because of that low pass filter. Now you have to take this is a state space equation in the form of vector. Now you have to find out that Laplace transform. You have to find out the transfer function, right? So for finding the transfer function is actually output divided by, so the Laplace transform of output divided by input. In that form, you have to convert it. So that output, the input is U of. Now you have to find out the ratio between Y of S and U of S. Now you have to take that Laplace transform. This is the differential. So in that differential, you have to multiply it with this. So the differential representing the Laplace transform is multiplication of term, right? So this is the Laplace x of s. So then time here we are having S domain, then we have to consider now S into X of S, and then here we are having now this matrix A, and this is directly X of S, there is no differential, then B and U of S. Similarly, for output is Y of S and C into X of S. So that here we are having now the Laplace transform of the equation. Then the Laplace transform is going to be rearrange so as to get the ratio between that Y of S and U of S. So how do you get now, right? So that one is here, X of S is take in the left hand side. So you are getting now that one as S minus A, right? This S minus A is nothing but Si. I is actually unit matrix, right? So that is here identity matrix, unit matrix, right? So identity. So that one is S and Si. Si. So that Si, then we are having now that X of S equal to then Si is going down. So Si minus A, the Si minus A can be represented by the inverse of Si minus A. Then so the U of S is going to come going to have the left hand side as determinant. So Y of S divided by U of S. So you are getting now that one as this output coefficient multiplied with that here Si minus A inverse, and then we are having now that input coefficients. So this is actually we have to. So for getting the transfer function, you have to do these operations. So you have to identify the C vector, B vector, and A vector. Then you have to do that this set of operation, right? So S of minus A, and then you have to take inverse of this matrix, and then you have to multiply this inverse of matrix with B, and then after getting that result, the result is multiplied with C. So this is actually post multiplication, this is pre multiplication. So you have to do for getting the transfer function. Where I told you that one, there is no t part in the here we are having now the t part is 0 because of you are considering now as low pass filter. So for low pass filter, that t equal to 0. So for all cases you have to consider now, right? Now we are going to solve problem. Okay. Now you have to consider now three equation, linear differential equation we are having now. So that one has, right? So this is you have to consider now, this is X vector, this is we are having now the coefficient matrix, then this is also X vector, this X vector coefficient differential. So you have to put it that dot at the end, right? So here we are having now, this is input coefficient B, and then here we are having now U. Similarly, for output, this is Y vector, and then we are having now this is C vector, and this is we are having coefficient, then this is we are having now X. Now using that one, then we are having the transfer function is here, right? Now that Si minus A. So this is A, Si minus A. So you have to do that one. S is here, I told you that one. Yeah, the diagonal is S, and then here the both off diagonal elements 0. So that is we are having now S of I. So S of I minus with that A. So you have to put that all symbol as, and you have to sum it now. So that is S plus 1, S plus 2 in the next diagonal, then S plus 3 is here, right? Now this one is you are going to have as minus 1. So this is also minus 1. So this is plus, right? Then the bottom off diagonal is all are 0, here also all are 0. Now we are getting now then Si minus A. Now for this particular Si minus A, we are going to find out the inverse. That one I have given in another lecture. So you another lecture as finding the inverse of the 3 cross 3 matrix as a lecture. So you check that one where I am getting now that some difference as here we are getting now that minus symbol, right? So here we are getting now the minus symbol. So that is you check now, you do that Si minus A inverse, right? So how do you make that inverse, and I have given in the another lecture. So you go through that lecture to find out the result, right? Then this result is going to be multiplied with that matrix, right? So this is actually Si minus A inverse, Si minus A inverse, Si minus A inverse. Right. This is multiplied with B, right? this is multiply with C. So this is multiplication. Then you are having this multiplication. We are getting now the result, right? In that result also, here the first term in the first term is 2 into S divided by here S minus S plus 1 into S plus 3, right? So you check that first term, right? All other terms are correct. Now you have to go through that. Okay. Then next example, with the simple example is 2 cross 2 matrix. So you can easily solve that, right? Now here also you have to consider obtain the transfer function of the system